Now let's see some basic configuration of the ACL. So first, we have to know how many types we can use on our network. The first type we usually use is IP standard ACL. And about this ACL, how to select the match, how to select the packets only can match the source IP address, and the keyword is the standard. But as we know, if we receive the message, source IP address only one part, right? And if you want to control more message to select the small traffic, right? Someone maybe say only the source IP address is too big. For example, I want to control the traffic from the same computer only about the web page, the port number 8. But if some normally office traffic, they still can visit, for example, to use a telnet to manage the device. In this scenario, you can use IP extended ACL. And about the extended, we can match the source IP, destination IP. We also can match the protocol and some special protocol information like the port number, something like this. And when you configure the IP extended ACL, the keyword is extended. And except this one, we also have the other, like the mic extend ACL, customer ACL, and IPv6 ACL. We can control the traffic depends on the MAC address, depends on some IPv6 information. And we will use different number to indicate different type of ACL. And the IP standard ACL is 1 to 99, and another range is 1300 to 1999. And about the IP extended, we also have two range. About the RCNA course, you only need to master the configuration of IP standard and IP extended ACL. It's enough, and you have to know the number, which number belongs to the IP extended. And about the IP extended ACL, you can match source IP, destination IP, ICMP type, TCP UDP, something like this. So you can select the packets according to more information. And later, let's say the configuration. About the standard ACL and the extended ACL, we can match different types of the data flow. About the standard ACL, we only can match the source IP address. So when you do the configuration, on the configuration page, IP access list and the keywords is standard. Then you can use the number because the range from 1 to 99 belong to the belong to the standard ACL. So this example you will use 13, right? In different ACL, you can use different number to distinguish with each other. And then you can take the action, and the action permit or maybe deny. Only have two actions. And then you can match your traffic. You can match the source address or maybe ANA or maybe host. Host means you only can match one source IP address, and the source address maybe means you can match the traffic according to the big range. ANA means everything. So this is the standard ACL. And about the extended ACL, we can match the traffic according to multiple protocols at layer 3 and above, includes the source IP address and the destination IP address, something like this. And the key configuration is IP access list extended and the port number like 101, and takes the action to become permit. Then you will find that we can match lots of protocols, right? EIGRP and GRE tunnel, ICMP, IGMP, something like this. And also you can directly to use the IP protocol number to distinguish different protocol, something like this. For example, why we can directly choose a permit OSPF. You also can use permit 989, the same meaning. So that means if you want to control more information to select the traffic, you can use extended ACL. And another one, how to indicate different ACL. The first one you can use is port number, right? Like the standard port number from 1 to 99 belong to the standard ACL. And you also can give some special name, have special meaning. But the basic one is you can use a port number. So which range belongs to standard ACL, which range belongs to extended ACL, you have to remember the range. But if you forget, it don't matter. You can add the question icon, and then here will give you some tips. What's the standard ACL? What's the extended ACL? And of course, you can give some special name. According to the name, maybe have different meaning, right? This ACL to control the traffic from department, or maybe this ACL to control the web traffic, something like this. So you also can define the name. And here is an example. We want the PC in VLAN 10 from accessing VLAN 30. You can define the special ACL name like deny VLAN 10 to VLAN 30. According to the name, it's very easy to understand, right? If you only have the number like 13, like 15, it's a little difficult. You have to focus on what's the detailed IP address, and then to consider about your network parameters planning, and finally you will find that this message belongs to VLAN 10 to VLAN 30. So you can use the command IP access list standard, except the number from 1 to 99 and 1300 to 1999. You also can provide the word. Some special name like deny VLAN 10 to VLAN 30. And then let's see the configuration of standard ACL. For example, now we want to forbid PC1's IP address 192.168.1.10, and the PC2 IP address is 192.168.2.10 to access data stream of any destination. We want to forbidden these two terminals. And we have to configure the standard ACLs and determine the ACL series numbers, right? Because different sequence number, we will have different matching sequence. And then we have to define the statement with the matching action. We take the action to become permit or deny, and what's the source IP range. And if we match the requirement, the key command is this one. IP access standard 99, and the standard is a keyword. Depends the message. You can choose only according to the source or maybe the other information. Standards that means you only can match according to the source IP address. And the 99 is this ACL name, right? This is ACL name, not about the entries number. And then you can take the action to become deny, because we have to forbidden these two PCs. So the action we take is deny. And then is IPs and the wordcast. And about the IP, if you only want to forbidden one IP, you can use the format like the first one, 192.168.1.10, and the wordcard is 000. And of course, you can use the special word host. Host is the same meaning if you only want to forbidden one IP address. So this is a standard ACL. But if you use extended ACL, for example, you can control more detailed information. Like this example, block PC1, the IP address 192.168.1.10, and PC2, 192.168.2.10. From accessing the data stream of PC3, the PC3 IP address is 192.168.3.10. If you use the standard ACL, that means all the traffic from PC1 and PC2 will be discarded. But this requirement will only want to stop the traffic from PC1 to PC3 and PC2 to PC3, but PC1 and PC2 still convey to the other destination. So if this requirement, we have to use the extended ACL. We also have to choose the ACL type to become extended, and then you have to define the statement and take the action to become permit or deny, and give the special entry information. And the example like this one, IP ACL list extended 101, and the extended is ACL type, and this is the ACL name. And later we will take the action to become deny, and the source IP, because we only want to block one special IP, so you can use a keyword host 192.168.2.10, and then to stop the other one, get the IP in an address pool. Of course, now we only want to stop with the PC3. If you want to stop with one segment, you can use a wildcard like 0.0.0.255.255, something like this. So this is extended ACL. But pay attention. Like the first example of the standard ACL and this example of the extended ACL, we only add two entries and both of them the action is denied. And pay attention, we see at the last we still have the default entry and the action is denied. That means if you apply this ACL on your interface, maybe in direction, maybe inbound direction, maybe outbound direction, all the traffic will be discarded. Because maybe some traffic from PC4, we cannot match the sequence 10 entry and also cannot match the sequence 20, right? But finally, we will match the last default action and the action is denied. So suggest to add an entry at the last, for example, permit any. That means you only stop these two streams and the rest of the traffic can pass through. So pay attention about this one. And another action if you have multi-statement configuration. For example, if there are multiple different access control requirements and you have to configure multiple statements and all the statements need to be defined in one ACL. For example, the request is first we want to forbid PC1 in the VLAN 10, here is the IP address, to access all the PCs in the segment of 192.168.4.0/24. This is the first one. And we also don't want the PC1 to wait the PC to the segment 192.168.5.0/24. And only special PC1 in the VLAN 10 can access to visit 192.168.3.0/24. Allows the PC1 to access the TCP port number 80 of 10.0.5.5. Other ports of this address are not allowed to access. And the rest data streams released. So this is the normal requirement in our real network. We want to forbid the PC1 to visit the two segments of 4.0, 5.0, and he can visit the segment to 3.0 and only allow the port 8. This belongs to the web traffic, right? Visit 10.0.5.5, but the other ports are not allowed. And then we don't have any limitation for the other traffic. So this is a basic requirement for us. And now if you want to meet the requirement, how to do the configuration. Of course, the basic routing information you have to use the static way or maybe OSPF to finish the routing successfully. Then you have to add the ACL to do the control. Let's see the configuration ideas. You have to determine whether to use the standard ACL or extended ACL. This is the first step, right? If you only want to forbid one source IP address, standard ACL is enough. But you want to allow some traffic of this source IP address, the standard ACL is not enough. You have to choose the extended ACL. And then you have to place the statement with the same format. What's the action, what's the stream type, and the subnet number, and the inverse mask exactly. All of the information have to do config when you add the entry, right? And then when multiple statements according to the requirement, you have to make sure the configuration sequence, the sequence number also is very important. Because if we have multiple sequence and we will match one by one according to the sequence number, lowest will be matched at first from bottom to top. So if you give some wrong sequence number, that means that this traffic maybe need to be discarded, but finally will be forwarded out. So there are three steps you have to know when you do the configuration of ACL. And finally, let's see how to give the special configuration to match the requirement. First, we select the type of ACL is extended, IP access list extended, and the name is for VLAN 10. You also can use the number like 101, but suggest to use the customer's name. And then the first sequence number, you have to permit the IP host 192.168.1.0 to the destination 192.168.3.0, and the wildcard is 0.0.0.255. This is a permit, right? This is a third requirement of this example. We allow the traffic pass through, and we will deny the IP address 192.0.0.0 and to wait the destination 192.168.4.0.0.0.255. And we also do not allow the PCs in VLAN 10 192.168.1.0, 0.0.0.255 to wait the segment of 192.168.5.0. So pay attention about this one. According to this ACL, we directly stop the traffic from the whole segment 192.168.1.0/24. So if your requirement you use only one PC cannot wait the destination, you can directly to use the host. Otherwise, if you want to stop the whole segment, maybe you can use a sequence number like this example, 192.168.1.0. And the next one, we want to the PC in VLAN 10 to access the TCP port number 80 to wait the destination 10.0.5.5, right? Other ports of address are not allowed to access. So the detail is 50 deny IP 192.168. Not about this one, the 40. The 40 permit TCP 192.168.1.0 and to wait the destination 10.0.5.5 and the port number is 80, EQ80. And the rest of the PC cannot wait this segment or the traffic. So we also add the rule 50, deny IP 192.168.1.0, and the wildcard is 0.0.0.255, and to wait the host number 10.0.5.5. And at last, we add the permit IP any. That means if the traffic not allows the sequence number 10, 20, 30, 40, and 50, all of the traffic can pass through. So this is the solution if you want to meet the requirement. This is a basic one. And in this process, the sequence number is very important, right? Because different sequence number will finally decide the match sequence. And all the sequence number can be automatically generated when you do the configuration. If you don't add the sequence number, it doesn't matter. This one will be automatically generated, and in the 10-digit increment by the default. And different discrete sequence number can be added in advance when configuring the statements in the ACL. For example, now we will give the IP access list extended, right? This is the basic ACL we do on the last page. And now if we want to add a new statement, for example, a new requirement is added. We want to block PC1 in the VLAN 10 from accessing the 192.168.6.0/24. We want to block this one. If you direct it to add the action deny and then give the PC1 segment and the destination is 192.168.6.0 and without the sequence number, this entry will be added to become the sequence 70. But about sequence 60, for example, about the sequence 60, we already allow IP any, right? So this traffic will never match the sequence 70. So in this scenario, you have to give a special sequence number and the value should be bigger than the 40. For example, like this example, we will use a 31. We will use a 31 to deny IP 192.168.1.0 and the wildcard is 0.0.0.255. And to wait, the destination is 192.168.6.0. Wildcard is 0.0.0.255. And the action is denied, but the sequence number is 31. So finally, when you check your configuration, the 31 will be added into the places after the 30 but before 40. So this sequence number is very important. And that's all about the basic configuration of the sequence number. Later, we also will have one video to explain how to do the application, how to apply the correct location.